Parabolas, day 2. So just like before with the other conic sections, our second video for this section will talk about what happens when the parabola has been translated so that the vertex is no longer at the origin. Okay, so today's topic starts out vertex at the ordered pair HK. So we have two formulas depending on which orientation, if it opens up or down or it opens right or left. And so we'll start out with the up or down version. And so it goes like this: y minus k equals 1 over 4p x minus h quantity squared. Okay, and so that's a parabola that will open up or down depending on the value of 1 over 4p. We also have x minus h equals 1 over 4p y minus k quantity squared. And so these are the ones that will either open right or to the left. Okay, so let's go ahead and do a problem and see how this works out. I'm going to give you y minus 3 equals 1/4 x minus 6 quantity squared. And your job is to come up with a graph and find the vertex, the focus, and the directrix. All right? And so we can tell by looking at this that because the x is squared and the y isn't, it's going to be of the form on the left and it's going to open up or down. We can also tell ahead of time, since the value in front of the x minus 6 squared is positive, that this is a parabola that opens up. And so I'm going to go ahead and find that vertex. Since it's x minus 6, then 6 is the x coordinate of the vertex, and y minus 3 means that 3 is the y coordinate. And so I'm going to go over 6 and up 3, and that will be my vertex. Okay? So I want to find the focus, and we know that when it's centered at the origin, all we have to do is find P, and we have the focus. It's a little more complicated when you don't start at the origin, but let's go ahead and set this value here, the 1 over 4 that's in front of x minus 6 squared, equal to the value 1 over 4p. So that's easy enough to solve. P turns out to be 1. And so from this vertex that was at 6, 3, we're going to travel up 1. Okay, I'm going to go ahead and draw my parabola in. I know that it faces up. And so from 6, 3, if I go up 1, I'm at 6, 4. So the focus is just one jump up from 6, 3, so it's at 6, 4. Okay? And then the directrix is a line. We remember it's a line that's on the other side. Boy, that's a fat line. Sorry about that. It's on the other side of the vertex from the focus, and this 1 now tells us to start at 6, 3 and this time to go down 1, so we're going to go down 1, and the equation of the directrix will be y equals 2. Okay, so this is y equals 2. And so that's a complete graph with all of the things that you need to show to get full credit for a problem like that. Alright, so here we go. Sometimes we're asked to graph a parabola that does not look like a parabola, and so in this case what we need to do is complete the square. And we've done this a number of times with the other conic sections, so we should be very good at it by now. So here we go. We got the x on one side, the y squared on the other side. That's perfect. If it's not like that, what you want to do is separate it. But it's in the great form. We're going to go ahead and start out, first step, bring that 15 over. Move it over next to the x. Okay. The next step is we recognize that we can't complete the square when it says 2y squared. We need to have that y squared by itself. So what we do is we factor that 2 out. And then with the 12y, we're going to go ahead and factor the 2 out of that as well. All right. So took a 2 out of 2y squared, took a 2 out of negative 12y, and what we got left was y squared minus 6y. So the number that completes the square on that is 9. How did we get that? We took half of negative 6 and squared it. Okay, and then we have to be careful to balance the equation. What we really added here was not 9, but 9 times 2, so I'm going to go ahead and put a little plus 18 to show that I have to add 18 to both sides. So what I get is x plus 3 equals 2y minus 3 squared. Okay, at that point, the equation looks an awful lot like the one that we graphed before that. I'll go ahead and get you started on it, but I won't complete it. Because the y is squared and not the x, we know that it opens right or left. Because the 2 is positive, that means it's going to open to the right. Our vertex, we have plus 3 with the x, so that means we're going to go left 3, and minus 3 with the y, so we go up 3. So the vertex is actually at negative 3 comma 3. And then it's going to open to the right, so I can just draw this picture here. The parabola is the one graph that we give you a little bit of leeway in graphing. We're not so concerned about how narrow or how wide it is. On the ellipse, the circle, and the hyperbola, you're expected to use the qualities of the graph to make it look like it is. But you'll notice that my parabola shapes could be wider, could be narrower, and what you're being graded on is finding the focus, the vertex, and the directrix, so that the shape of the parabola is not as important. Okay, so vertex is at negative 3, 3. We're going to set 1 over 4p equal to 2, and so p turns out to be 1/8. And so from negative 3, 3, we're going to go 1/8 in to the right for the focus, and so that would be negative 2 7/8, 3. That's kind of a challenging number. We don't ever like to use mixed numbers, but in this case I think that negative 2 7/8, it's much easier to see that I've gone 1/8 to the right. I'm going to go 1/8 to the left and draw this directrix, and so it's going to be the equation x equals, and if I'm at negative 3, 3 here, when I go 1/8 to the left, I'm at x equals negative 3 1/8. Okay, and so that's a complete graph after completing the square. All right, one more problem. Sometimes to challenge you, they try to give you a little bit of information and ask you if you can come up with the equation. So what about if I tell you it's a parabola? And these are the only things I know, that there's a focus at 3, 0, and the directrix has an equation of x equals negative 3, and your job is to come up with the equation. So let's go ahead and put that on a graph and see what it looks like. Here is the focus, 3, 0, and here is the directrix, x equals negative 3. And so we haven't actually said this, but the vertex of a parabola is always halfway between the focus, the point that's the focus, and then that point on the directrix that's closest. Okay, so if this is at x equals negative 3 and this is at 3, 3, 0, I am certain that the vertex of my parabola is 0, 0. The other thing I'm certain of is that it's going to open up to the left, and here's why. If it opened to the, it's going to open to the right. I drew it to the right and said left. It's going to open to the right because it has to cradle this focus on the inside. If it opened to the left, it would run right over that directrix, and that doesn't happen. So I know that this is going to be the equation x equals, the y will be squared because it's opening to the right, and so 1 over 4p, and p is this distance from the vertex to the focus, and so we can see p is 3, and so the equation of this specific parabola that I gave you would be 1 over 12y squared. Okay, so these are 3 more challenging problems. You'll have a lot more like this in the book when you do your bookwork in class. See you tomorrow.